All right, let's go ahead and look at questions 3, 4, and 5. Hopefully, that shouldn't take as long as questions 1 and 2 did so far. I've already kind of explained a couple of aspects of 3, 4, and 5. So, in question 1 and 2, firstly, question 3, we've already answered with question 1, right? It reads, leading coefficient A indicates really important information about the graph. State exactly what A indicates. Be very specific in your response. That's already up here. That's circled in brown. This is exactly what A indicates, and this is the detail I was looking for. First, A indicates concavity. If your graph or parabola is going to be concave up, if your leading coefficient is positive, or if it's concave down, having a negative leading coefficient. So A indicates that one aspect of the graph. The second aspect is also if it's going to be a vertical stretch or a vertical shrink. Vertical stretch is if you have a leading coefficient that's equal to 1 or greater than 1, or you could have if your leading coefficient is going to be equal to -1 or less than -1, right? So if we were to draw like a very small number line, right, to show this one, so I have a number line, I have -1 here, and I have 1 here. What we're trying to say is that any value of the leading coefficient of A that's going to be equal to 1 and greater, or if it's equal to -1 and less than -1, any one of these values that are within here are going to provide you with a vertical stretch. You're going to have a skinnier graph because you're multiplying your value that you have for your equation in here. So basically, look at what we did over here. We multiplied for our question 1, we multiplied our value of 1 right here, 1 squared times this -1. Now imagine now if this -1 would have been a -6 or like a -5. That's going to make your y value that much greater because now you're multiplying this value that you have when you of inside this parentheses times that leading coefficient. So we're talking about this value right here, this leading coefficient. If that say it was a -6, -8, -9, now we're multiplying 1 times -9, which is going to make your y value that much larger. But now it's also on the other end, let's say that we had a -1/2. So now you're multiplying 1 times -1/2, which makes it like a -0.5. So now our y values are going to shrink and be much smaller. That's where that vertical stretch versus vertical shrink comes into play. So now here, now the number line was some extra I did just now, but everything I have in this, it's circled in brown, is exactly what I wanted you to be able to say for question 3. Some of you mentioned like maybe concavity, or some of you may have mentioned vertical stretch and shrink, but very few of you talked about both of those at the same time. That's exactly what your leading coefficient indicates. Your leading coefficient indicates concavity, up and down, or vertical stretch versus a vertical shrink. So that's the answer for question 3. Question 4, to sketch a graph with the minimum vertex of 4, 5. Now, I had a couple of students email me and say, hey, Mr. Lake, you didn't give us an equation. You didn't let us know if it was concave up or concave down. Actually, I did by the word minimum. The word minimum tells you a lot about the graph already. So now let's go ahead and write over here. So I'm going to put minimum here. And I'm going to put maximum over here. So now for the minimum, no, let's do maximum first, right? So for maximum, let's say I have two different types of parabolas, right? I have a concave up, I have a concave down. Now let's go ahead and plot a point where the vertex would be on both of these examples, right? We're here. Now, which one of these is a max vertex, or like the highest point on the graph? That's going to have to be this example right here. This is a max vertex. But what that means is that, and we're going back to just what we did for question 3. We're talking about concavity here. So this is going to be concave down. So that means that you have to have a leading coefficient that is negative. So if it tells you already that you have a maximum vertex, okay, boom, I know that it has to be concave down because the highest point is my vertex, the highest point on the graph. And if it's concave down, that means that A has to be, the leading coefficient has to be negative. Conversely, now if this graph over here was a concave down for a maximum, that means that this graph over here, which is going to be concave up, and that means that it's a minimum. This is the lowest point on the graph, so that means that A has to be positive. So we've already talked about a couple of small things just based upon the word minimum and maximum. So that means that we can draw a sketch. Now, all I wanted was a sketch, so it didn't have to be accurate. You didn't have to have 5 points for this. So I just wanted to see what you were thinking. So I know that I have a minimum vertex of 0.45, so I'm going to go 4, 5. And since it's minimum, it means the graph has to be concave up. Now, I didn't give you a lot of space for this, my apology, but either which way it go, we can go ahead and just kind of draw a little bit of a sketch here. And mine comes out a little nasty, but we're fine. As long as it's concave up with a vertex at 4, 5, we are good to go. And this is a minimum point because this is a minimum vertex because it is the lowest point on the graph. So it's a minimum vertex at the point of 4, 5. So that was question 4. Just minimum vertex of 4, 5, but we understand would it be a minimum, it has to be concave up because it's the lowest point on the graph. And in order to have a lowest point on the graph, your A has to be positive. So all those different factors come into play looking at this particular question. Last one, question 5. Now, question 5, I was kind of getting to what we already did up here for question 1, where we're kind of using the axis of symmetry as a line of reflection. So we can graph one point and then reflect it over the AOS. So now let's see how we can make this work. 3-column table. I gave you space provided, but I'm going to need a little more space. So I'm going to go ahead and draw a 3-column table over here. This is x, this is f of x, and then that's going to be the function in the middle there. Now, I don't think I have a lot of space in here to work it out, but I have all the space I need down here. I'm supposed to have another graph, too. I didn't make another graph. I don't know if I can do it down there. I'll make it work. We'll be okay. I'll see. All right, so then now here what we have, we talked about before, right? Let's identify what we can by just looking at the equation. So first off, I'm going to just go what's real easy. I'm going to go with the vertex. The vertex is going to be, we talked about this sign means opposite. What's the opposite of -3? It's going to be +3, right? So, or what's the opposite of 3 in this particular, well, no, it's the opposite of -3. So then now we're going to say the vertex in this case is going to be 3 and the 3 and -2. That's our vertex, right? But now, is it a lowest or a highest point? Well, this value of this fraction here is positive. So since it's positive, since we have our A is positive, we just talked about it earlier, it means we're going to be concave up. So it's going to be concave up for our graph. So now we know the shape of the graph based upon the value of our leading coefficient. And now A is also a value that's in between -1. I don't like that. That's getting too close to my table there. All right, so A, let me just go down here. And we also have the leading coefficient is also a value that is in between -1 and 1. And now with that being the case, let me see, is it equal to? I forgot where I put it. Where's it at? Oh, it's up here. I'm sorry, you guys. Yeah, so it's in between -1 and 1, right? A is just half in between -1 and 1. That means that we're going to have what? A vertical shrink. Our y values are going to now be much smaller because we're going to multiply that parentheses, that x minus h squared, we're going to multiply that times a fraction. It's going to make that value much smaller than what it could be. So it's going to shrink down our y values. So we know that it's going to be concave up. We have a vertex point at 3 and -2. So let me put that there if I can graph on this little tiny thing. 3 and -2. Oh, I can't. There you go. Perfect. 3 and -2. We know it's going to be a vertical shrink, so it's going to be a little bit of a wider graph when we start finding points. Oh, and then also, what is our AOS? Now, we know our AOS is the formula x is equal to h, and that was given to you on that vertex form handout. Go back into our blog, look at the beginning of April. I think it's like either the second or third day, we had the vertex form study guide. AOS is x equal to h. And we know our vertex is h and k. So our AOS is whatever our h is for our vertex is the exact same value we're going to have for our AOS. So AOS is x equal to 3. And we said it earlier, right? It makes sense that if the AOS puts the graph in half, then it should be cutting right through your vertex. So that point has to be on that line. This is going to be tricky because it is really tiny. It might not be as neat as it could be. I'm going to label that. X equals 3. Oh, that's sloppy. Sorry about that. X equals 3. We know that it's going to be concave up, so I'm going to go ahead and go right down here. I'm going to put vertex of 3 and -2. Okay, so now let's look at a couple of points, and then I'm going to show you how we're going to use our axis of symmetry as a line of reflection like I did above for question 1. So let's look at, let me see, my AOS is x equal to 3, so I want to use 2. 2 is right next to it. So let's go, I'm going to pick a different color here. So let's do, I'm going to go f at 2 equals a half times, oh, sorry about that. So we already know what it is. 2 minus 3 squared minus 2. So we have f at 2 equals a half of -1 squared minus 2. F at 2 equals a half of 1 minus 2. We know half of 1 is going to be 0.5. So half of 1 is going to be 0.5 minus 2. And 0.5 minus 2, let me see. Let me see, 2 minus that. Did I do something wrong here? Oh, no. Half times 1 is a half. Half minus 2, this is a -1.5. But that doesn't make any sense. So what did I do wrong here? Because it's concave up. So there's no way you're going to have 2 and -1.5. That would work if it was concave down. But this is not down. Oh, what I do? Let me see here. Let me see. We're going to figure this out. X equals 3. 2 minus 3 is 1. 1 squared. 1 times a half is just a half. 0.5 minus 2. What am I not looking at here? I got this video going. I messed around and made a mistake. I can't find out where it is. 3 negative. Oh, no. I apologize, you guys. I'm over here thinking that the vertex was above the x-axis. I wasn't paying no attention at all. The vertex is below the x-axis, so this works. So my apology, took all this time and didn't even make any sense. So I had x is 2, and then the y is -1.5. So I have an ordered pair of 2 and -1.5. I totally took all that time for nothing. So 2 and -1.5. So I go over 2. I'm going to go down 1.5. This is going to be a very small graph. So over 2, down 1.5. I know I should have made it a bigger one. So, but I do hope, though, that if you are rewriting this, which I'm going to put in the email when I send this out to all of you, need to rewrite every single one of these problems you don't understand on a separate sheet of graph paper, separate note paper, and to make sure this graph is bigger so that way it's not as small for you as it is for me. Excuse me. So, but excuse me. But now I have my AOS, right? My AOS is x equals 3, but it also acts as a line of reflection. So now I'm at my point of 2 and -1.5. I'm 1 unit away from the AOS. I'm going to go 1 unit on the other side. So now I have a point at 4 and -1.5. All right, I have 3 points there. So when you derive 1 point, you're in essence, you're already finding 2 because we're just going to reflect it over the axis of symmetry. Now let's go ahead and find the other point, right? Now let's go ahead and find f at 1. So that was f at 2. Now let's find f. I want to change the color. I want all the work to be done in purple. So now we're going to find f at 1. So now we're going to have f at 1 equals a half times 1 minus 3 squared minus 2. Then we have f at 1 equals a half times -2 squared minus 2. F at 1 equals a half times 4. minus 2, half of 4. You see, right here, this is what we're talking about, that stretch versus shrink. Now we're taking half, I don't want to do that. We're taking half of 4. Half of 4 is 2. Now, just think about if this half ended up being a 9 or being an 8. We'd have 32 minus 2, which would be 30, instead of half of 4, which is 2 minus 2, which is going to be 0. So we'd have a 30 minus a 0. So just look and see how much wider or how much skinnier the graph would be if I'm going to have a point of 1 and 8 as opposed to now 1 and whatever number I'm about to get now. So it makes a big difference if it's going to be a stretch versus a shrink. So now I have f at 1 equals half of 4 is 2, and 2 minus 2 is 0. So I have f of 1 equals 0 here. So over here for my 3-column table, I have 1 and I have 0, so my ordered pair is 1 and 0. Let's go back to this tiny graph over here. I have a point at 1 and 0. And if I've gone too fast, I apologize, but that's why it's a video. Please go back and make sure you take your time, record it, relook at the problems, and email me whatever questions you have. So I have a point right here at 1 and 0, but I want to use my AOS to be able to reflect this point. That way you see I've only done work on 2 points, but now I've already found 4. So now I'm going to go 1, 2, and then 1, 2. So when I found a point at 1, 0, I can reflect it, and now my other point's at 5, 0. So now let's go ahead and just kind of complete the curve, make it nice and pretty here. And that's going to be the graph that we have of the formula f of x equals a half of x times x minus 3 squared minus 2. But we use our AOS as a line of reflection, did work for 2 points, reflected them, and found the other 2 points. These are questions 3, 4, and 5. I want to put in the email that I suggest that every single one of you recopy these notes down and make sure you have it where it makes a little bit more sense, a little bit more clear. I might provide extra credit over the weekend. So that way you can go ahead, rewrite all of this down, have the graph down, show me that you've done the work, and then I get some extra credit for you guys because I know some of you need it, but I want to make sure this information is detailed and that you have it down. Yeah, so please go back, look at the videos, rewatch it, make sense of it, and then we'll keep going from there. Advocate. Let me know how I can assist you. Let me know what I can do. All right.